IGCSE Energy, Water, and the Environment. Okay, so first some definitions. What is non-renewable energy? Well, it's energy that can't be reproduced in the time that it takes to consume it, like coal. For instance, we do burn coal at a faster rate than we get new coal, so it's non-renewable because we will eventually run out for a time being. What is renewable energy? Well, it's exactly the opposite. It is energy that is naturally occurring and is potentially infinite, so it will never run out. Non-renewable energy is finite, but renewable energy is infinite. Okay, what's a fossil fuel? Well, a fossil fuel is any combustible organic matter that is made from the remains of former flora and fauna, which are animals and plants. So, what is a raw material? Well, very simple, it's just any unprocessed material, just raw, unprocessed, untouched. Okay, the global energy. It might help if you look away from the screen and just try to listen to me, because then it's easier. As the world's population continues to grow, and as the level of development of people and countries continue to grow, so does the demand for energy. In traditionally less developed societies, the main source of energy tends to be fuel wood. Fuel wood can be used for heating, cooking, and even scaring away wild animals. Fuel wood being, wood that they use for fuel and that they get from taking down trees or something. As countries begin to develop, they can begin to afford more raw materials and to build power stations. Most commonly, fossil fuels are burned because the technology exists and at the moment they are widely available. However, as countries develop further, their sources of energy may change again. They will probably still be heavily dependent on fossil fuels, but will begin to use more renewable energy and probably more nuclear energy. The reasons for the changes include, firstly, greater concern for the environment, because we all know how bad fossil fuels are for the environment. The rising prices of fossil fuels, it will become too expensive. Also, the knowledge that fossil fuels are finite and will eventually run out, and the aim to reduce reliance on fossil fuel exporting countries. Because, for instance, if there's the USA and, I don't know, Canada, let's say the USA gives Canada fossil fuels, but then the next day they're in a war, then Canada won't have anyone to give them energy. So they're trying just to reduce dependency on it. Also, they want to have improvements in renewable technology. And, well, these already exist. And also, they have hope of developing and selling renewable technology. And also, better technology and increased stability allows nuclear development. Because we're now, it's more safe now to have a power station than it would, like a nuclear power station, than it would have been a few years ago. But there are always some exceptions to the rule. For instance, Costa Rica gets the majority of its power from renewable sources, and countries like Lithuania and France get nearly all of theirs from nuclear. Okay, so now let's look at some advantages of using coal for energy. Well, firstly, energy production using coal can be increased or decreased according to demand, and the technology to burn coal to generate electricity already exists. But there are disadvantages. Firstly, coal is finite, so it will eventually run out. Also, many existing reserves are becoming harder to extract or are in environmentally sensitive areas. Coal releases large amounts of greenhouse gases when burnt, and mining deep underground coal is extremely dangerous. Coal is very bulky and expensive to transport around the world. Now, natural gas, another fossil fuel. What are some advantages? Well, energy production using gas can be increased or decreased according to demand. The technology to burn gas to generate electricity already exists. Burning gas releases less greenhouses than coal and oil, and it is now possible to compress gas and transport it more easily. What are some disadvantages of gas? Well, gas is finite, so will eventually run out. And a lot of gas is located in politically unstable countries or environmentally sensitive areas, so even just getting access to it is quite tricky. Also, gas is vulnerable to leaks and explosions, which can potentially be very harmful to both people and the natural environment. So, what are some advantages of using oil, another fossil fuel? Well, energy production using oil can be increased or decreased according to demand, as with all the fossil fuels like we just stated. But the technology to burn oil to generate electricity already exists, so we don't need to have some complicated and expensive research. Also, technology is improving to extract deeper reserves as oil in tar sands. But there are also some disadvantages. Firstly, oil is finite, so will eventually run out. Also, a lot of oil is located in politically unstable countries or in environmentally sensitive areas, such as Libya and Iraq. Oil can cause widespread pollution when spilt. For instance, look at the BP oil spill in the Gulf. Okay, what else? So oil also releases large amounts of greenhouse gases when burnt, which is never a good thing. And it's vulnerable to large-scale changes in its price, which can be really harmful to economies. Also, lastly, the production of oil refineries is extremely expensive. So, let's look at exactly the opposite kind. Now we just spoke about non-renewable types of energy. Now we're going to talk about types of renewable energy. So, solar energy. This is when we use the power of the sun to heat water or to generate electricity. What are some advantages of this? Well, it is a clean form of energy. It is an infinite resource. It will never run out. The panels can be used locally, for instance, on top of someone's house. And it can be used to heat water and generate electricity. What are some disadvantages? Well, it's very expensive to make solar panels. And the sun doesn't always shine, and not every country gets enough sunshine. And the solar panels also can't be used at night, so we won't have electricity at night. And it's hard to store extra energy because it doesn't really have a storage place. And the supply doesn't always equal the demand, so perhaps there's not enough sun for how much people want it. Okay, wind power. This is when you use the power of the wind to drive a turbine to generate electricity. What are some advantages? Well, it's a clean form of energy. It is an infinite resource. It can be used on a local scale, for instance, in your back garden. And the technology is, already there. And they can be placed at sea or in mountains away from settlements. What are some disadvantages? Well, visual pollution. There's a phrase we call NIMBY, which stands for not in my backyard. People agree with the concept of it because, they like the fact that it's environmentally friendly, but it's a very ugly kind of huge wind turbine thingy. So, they don't actually want it close to them. They don't want to see it. So that's a disadvantage. Also, it's very loud, so there's noise pollution. And wind is unreliable. Some days there can be absolutely no wind, and then there's no electricity. Also, they're extremely expensive to install, especially offshore. And it is hard to store surplus energy. And they do have to be turned off in extremely strong winds. So, tidal energy. This is when you use the incoming and outgoing motion of the tide to generate electricity. Some advantages would be that it's a clean form of energy. It is an infinite resource since tides happen twice a day, and it's ideal for island countries. Some disadvantages, though, would be that A, it can block important shipping routes. B, it may interfere with some animals like sea otters and seals. C, limited number of sites, so it can't be placed anywhere. For instance, if you're a landlocked country, you can't do it. Then also, it's useless, like I said, it's useless for landlocked countries. Also, it's extremely expensive to start up, and the technology is still being developed. And it may be damaged by tropical storms. Okay, so wave energy. This is when you use the motion of the waves to generate electricity. So, what are some advantages? Well, it's a clean form of energy. It is infinite and it's ideal for island countries. But there are disadvantages. Again, it can block shipping routes and interfere with animals. Again, not suitable for landlocked countries, and the strength of waves can vary, and it may be damaged by tropical storms. Also, the technology for wave energy is also being developed right now. Okay, hydroelectric power. This is when you use the power of falling water in rivers to drive generators. At the moment, dams have to be built to create hydroelectric power stations. So, some advantages. Well, it is a clean form of energy, and it's finite as long as the rivers are managed properly, and the built dam can also prevent flooding, and the reservoir behind the dam can be a store of water. However, there will be disadvantages, of course. Firstly, only a limited number of suitable rivers exist in the world that we can use for hydroelectric power. Also, it can hamper navigation up and down the rivers. And reservoirs may force resettlement, such as the case in communist China for the Three Gorges Dam, which we'll look at later. Also, the migration patterns of animals may be disrupted, which is never a good thing. Also, dams reduce the deposition of alluvium downstream, which is a con because if there are farmers, they rely on the deposition of alluvium to make their soil really rich in nutrients and minerals. Okay, so dams can also flood large areas of land, which we know is not good. So, biofuel. The use of biological matter to create energy. It is a renewable form of energy, but because the matter is so often burnt, it still releases greenhouse gases. Some good things to this is that it's renewable, so as long as people always replant crops, and it's cheap and the resources can be grown locally. However, it can still release greenhouse gases, and areas can be deforested to grow crops for energy generation. And if crops are used for energy production, it can lead to an increase in food prices. Since, okay, look at it like that. Farmers basically usually farm food, and there's lots of food, so it's not very expensive because there's lots of supply. But now farmers are realizing they can make more money by growing crops for energy generation. So they do this. So less farmers are actually making food. So there's less supply, but there's still the same amount of demand. So the food will have to become more expensive. Okay, geothermal. Geothermal energy uses thermal energy from the earth to heat water. The water can be used as a source of hot water, or the steam released can be used to drive turbines. Some advantages would be that it's a clean, renewable form of energy. It's finite. It can be used to heat water and or generate electricity. And geothermal energy can be created constantly and is not dependent on the weather, like many others are of renewable energy. But there are some disadvantages. Firstly, not every country has geothermal potential because it needs to be kind of a volcanic area. So, for instance, New Zealand could do it, but Monaco couldn't. Okay, installation and startup costs are extremely expensive to first build the whole thing. Also, when you drill inside the earth to, get access to this heat, well, it can release harmful gases. Lastly, geothermal activity can change, and this can make the production of energy a lot harder. Okay, so now let's look at some advantages of nuclear energy, which is non-renewable, but some consider it as renewable because there is just so much available. So the technology to make it already exists, so that's an advantage, and there's a plentiful supply of uranium, enough to last for hundreds of years. Also, nuclear energy releases very low amounts of greenhouse gases, and it reduces the dependency on oil, coal, and gas-producing countries. Nuclear waste can also be safely stored underground, and the supply of electricity can be altered depending on the demand. But there are also many disadvantages. Firstly, there's always the risk of nuclear accidents, such as the Chernobyl accident in the Ukraine, which killed many, and injured them too. There's also a risk that nuclear power stations will become terrorist targets, or that nuclear material will fall into the hands of terrorists. Countries can also use nuclear technology to make nuclear weapons. North Korea and Iran have both been accused of doing this. I'm sorry. Okay. Transporting nuclear material and nuclear waste is also very risky and expensive because if there are any kind of problems, it takes a lot of money and risks to clean up after this dangerous nuclear radiation is released. Also, nuclear power stations only have a limited life period, and the cost of decommissioning them is extremely expensive. And there is belief that living next to nuclear power stations can increase the risk of cancer, such as leukemia. And many people like the principle of nuclear power stations, but they don't want them built anywhere near to where they live, because it's, again, a NIMBY, not in my backyard kind of thing. And also, mining for uranium is very dangerous and can be polluting. Also, lastly, nuclear waste remains radioactive for thousands of years. So, if there are any storage problems with it after you dispose of the waste, for instance, if the boxes break or there are some kind of issues, the radiation can still escape and harm people. So, moving on, fuel wood. Fuel wood is the most common source of energy for people living in less economically developed countries. It is estimated that about 40% of the world's population relies on fuel wood. It's often the main source of energy because countries either can't afford to buy raw materials to produce energy, don't have the technology or money to build and operate power stations, and certainly don't have a national grid to distribute energy. Fuel wood has multiple functions. It can be used for cooking, heating, and even scaring away wild animals. Although using fuel wood is essential for many people, it can cause environmental and social problems, such as deforestation, biodiversity loss since vegetation is removed, so animals lose their homes, desertification and reduced rainfall, increased soil erosion and increased sandstorms, increased time spent looking for wood, so children may have to be taken out of school to look for wood, and dangers posed by collecting wood, such as wild animals and criminals, the dangers of breathing in harmful smoke from when you burn the wood inside houses, and the risk of fire within houses when you burn it. Okay, let's look at a case study now of a power station. We're going to look at the Three Gorges Dam. The Three Gorges Dam is the largest hydroelectric power station in the world. The dam is over 2 kilometers wide, and it produces 22.5 thousand megawatts of electricity. The hydroelectric power station is located on the Yangtze River in central China. Do remember the word Yangtze because this is a place-specific reference and will give you an extra point. So it's located on the Yangtze River in central China. And China is one of the most populated countries in the world, and the Yangtze is the third longest river in the world. So the site of the Three Gorges Dam was chosen over 15 other sites in China. Its location was picked for the following reasons. As the third largest river in the world, the river offered huge hydroelectric potential. The river valley was wide and flat, which meant that building on it was extremely easy. Also, the bedrock was firm and with limited cracks, so it would be strong and wouldn't collapse. Also, there was a small island in the river channel, which made it very easy to create a diversion channel during building. And despite large parts of China being volcanically active, the area around the dam has not suffered any recent major quakes. And, however, there were some towns and cities that were very close to this valley and needed to be relocated and resettled somewhere else. But in communist China, this was extremely easy. So, the government relocated people to places like Fengdu, which is another place-specific reference. So, China also has a huge population of over 1.3 billion people, so it was extremely easy to find workers to, help build the station. So now some definitions. Firstly, groundwater. This is water found underneath the surface of the earth, so underneath the ground. And surface water is exactly the opposite. It's water found above the surface of the earth. So, where is the earth's water? Well, the majority of the world's water is seawater. This leaves about 3% left because this seawater it makes up 97% of the world's water, but the other 3% may be potentially useful for humans. However, out of this fresh water, the majority is frozen, about 69%, or under the ground, about 30%. This means that only about 0.01% of the Earth's water is useful and easily accessible. You don't need to know these statistics, by the way. In terms of surface water, the large continents of North America, Asia, and Africa have the most. Australia has a very dry climate, especially towards the center, where it has very little surface water. But every continent has a large supply of groundwater. However, groundwater can be hard to extract because it can be very deep underground and often large distances from where it is needed, which makes extraction and transportation very expensive. Although groundwater is useful, unless it's managed properly and replaced, it can cause problems like sanitation and ground subsidence. So even though the world has a lot of frozen water, like glaciers and ice caps, the water isn't useful because you would have to melt it, releasing large amounts of greenhouse gases and altering local ecosystems. And then you would have to transport it large distances to where it is needed. So how is water used? Well, agriculture is by far the world's biggest user of water. Water is used for animals, but the majority is used for irrigation, which is when you water the whole crops. The amount being used by agriculture is also increasing as the world's population increases and the demand for food increases. Household or domestic use is the next biggest user. The most water is usually used in toilets, but also washing machines and shower/bath use significant percentages. Industry and energy production also use large percentages in manufacturing and cooling processes. The fourth biggest user is actually water lost through evaporation and leaks in reservoirs. So groundwater. Like we said, it's water stored under the ground. Water can be held in porous rocks called aquifers. With increasing demand for water, groundwater is being demanded more and more. So what's an aquifer? An aquifer is a rock that can hold water. Aquifers are called confined if they are surrounded and contained by aquetards and aqueludes. Unconfined are not contained by aquetards and aqueludes, and instead their upper limit is the water table, but you don't need to know about that. If groundwater is not used in a sustainable fashion, i.e. more is taken than is replaced, then it can cause a number of problems, including salinization. This is when there is an increase in the salinity, so the salt content of water. Salinization may happen if more water is being removed from an aquifer than is being replaced, so this causes the concentration of salt to increase. Also, saltwater intrusion. When aquifers near the coast are depleted and saltwater leaks into the aquifer, it changes its salinity, which can affect animals, or even just plants, any aquatic kind of life. Subsidence. This is the collapsing of the ground. Ground may collapse if water has been abstracted, which means removed, from an aquifer underground. Parts of Mexico City are subsiding because of over-abstraction. Okay. Some terms. So economic water scarcity. This is when water is available, but for some reason it is inaccessible or unusable. This might be because it's groundwater and it's expensive to extract, or simply that the cost of transporting it is too expensive, or perhaps even that the supply of water has become polluted. So, physical water scarcity. This is when there is not enough water available. The most common reason for this would be low precipitation rates. Water stress is when the demand for water exceeds the supply of water, causing water shortages. Water shortages are known as droughts. Water stress basically happens when demand exceeds supply, so more people want it than there is, water. And below are some of the main reasons why demand is increasing and supply is falling. So why is the demand growing? Well, population growth. As with many of the world's resources, they are coming under increasing pressure as the world's population grows. The world's population now stands at 7 billion, all of whom are placing an increasing demand on water resources as they develop and get richer. Also, domestic demand. The demand from households is not only increasing because there are more households in the world, but also because the amount of water they want is increasing with development. For example, as people's income increases and they move into permanent residences, they demand flush toilets, baths and showers, washing machines, dishwashers, and green gardens, all of which use large amounts of water. Also, the agricultural demand. As can be seen below, agricultural places by far the biggest demand on water. With a growing population, global warming, and the movement into less favorable agricultural regions, the demand from agriculture is only likely to increase in the future. So, industrial demand. As the world's population grows and becomes richer, our demand for industrial products grow. Many industrial products, particularly things like metal making, use huge quantities of water and place increasing demand on resources. Also, mining for the raw materials used in manufacturing use large quantities of water. Lastly, energy production. Although hydroelectric power is the most obvious form of energy that uses water, this water is released into rivers once it has passed through the dam. Other types of energy that uses large amounts of water for cooling, like coal and nuclear power, may pollute water or see it evaporated, removing it from local use. So, what are some reasons for the supply of water falling? Well, firstly, climate change. Climate change is impacting the availability of water in many, many ways. Global warming may be releasing fresh water from glaciers and ice shelves, but unfortunately, much of it is running directly into the oceans. The subsequent rising sea levels are threatening many coastal freshwater wetlands, as well as increasing the risk of saltwater intrusion into aquifers. Warmer temperatures are increasing the amount of evaporation from rivers and surface stores as well. So, groundwater depletion. If water is used unsustainably, so more is taken out than is being recharged, then aquifers can suffer from salinization and saltwater intrusion. If you increase the concentration of water, it can become too salty for humans to use. Also, if you drain aquifers near coastal areas, then they can become full of saltwater, again making them useless. Sewage. With rapid urbanization taking place in many cities around the world, infrastructure often does not keep up with new arrivals. The growth of informal settlements without proper sewage treatment can mean that human waste is often pumped directly into water sources. However, this is not only a problem in LEDCs. In London, the sewer system cannot cope, and an estimated 39 million tons of sewage are dumped in the River Thames annually. And that obviously pollutes the river, and then we can't use that as drinking water anymore. So, pollution. As the world's population grows, so does the demand for agricultural and industrial products. Our thirst for agricultural products is increasing the use of fertilizers and pesticides, which often run off into rivers and lakes, or leach down to groundwater stores. Likewise, our increasing demand for industrial and at times relaxed environmental regulations mean that more chemicals and metals are being released into our water sources. Sewage treatments also often lags behind population growth, so increasingly our rivers and lakes are becoming polluted by sewage. So, politically, in some countries or regions, water sources are shared. For instance, the River Nile flows through 11 countries. At times, some countries control large percentages of the shared resource, leading to shortages for other countries. Egypt and Sudan historically control much of the Nile's water and refuse to let other countries along the Nile use it. Mismanagement. If water is not used sustainably or used inappropriately, then water shortages can occur. One of the most famous examples is the Aral Sea. This is located near the border of Kazakhstan and Uzbekistan. Basically, water was taken from the two rivers that fed the sea to irrigate the desert and grow cotton. Unfortunately, so much water was needed to grow cotton in the desert that no water ended up reaching the Aral Sea, and it began to dry up, causing huge water shortages. So, yeah. What are some problems that are caused by water shortages? Well, firstly, obviously, drought. If there are economic or physical water scarcity and water stress exists, then a drought can occur. Drought is below average supply of water over a prolonged period. Because drought is below average supply of water, even relatively wet countries like the UK can suffer from drought. That should be countries IES. Sorry about all these spelling mistakes. I keep seeing them. Crop failure. If there is a shortage of water and farmers can't irrigate their crops, then then their crops may begin to die, and so will the farmers because they don't have food left. So yeah, that's another problem. And livestock death. If livestock, as in the animals, the cattle of a farm, don't have enough water to drink, they will begin to die. And famine. If crops are failing and livestock is dying, YING, then people will become undernourished and suffer from famine. Also, groundwater depletion. If aquifers begin to dry up or are used unsustainably, then the ground above can subside, as in collapse, or the aquifer can suffer from salinization or saltwater intrusion. Conflict. If there is a limited supply of water and water resources are shared, conflict can arise. The ongoing border dispute between Israel and Palestine is often blamed on water shortages. Refugees. If there is drought and famine, then people are forced to relocate or simply to face death. Unfortunately, many of the countries that suffer from drought and famine have poor neighbors, so refugees will be arriving in countries that are least able to cope. Yeah. So, disease. Dirty water can attract mosquitoes, which can increase diseases like dengue and malaria. Dirty water can also spread the diseases like hepatitis A and typhoid, as well as things like diarrhea, because water is, dirty water can, if you drink it, you may get those things. Eutrophication. This is when runoff from farms containing fertilizer can lead to eutrophication. Eutrophication is the excess growth of algae causing water to not oxygenate properly or receive enough light. This can cause plants and animals to suffocate and die. Basically, you have crops. Well, farmers use fertilizers, and these fertilizers eventually run off, like along with rainwater and all that jazz, into rivers. And these chemicals, they're fertilizers, so they're supposed to make the crops of the farmers grow quicker. But since they run off into actual rivers or lakes or anything, well, they encourage the growth of algae, which are the plants underneath. And as we all know, plants do use oxygen. Well, yeah, and so a lot of oxygen is being used by the algae. So, um, and so it's also growing, and other fish and other animals aren't getting enough oxygen, and the algae is growing so much that it takes all the light, and this can cause plants and animals to suffocate and die. Also, a biodiversity loss. Dirty water and eutrophication can cause loss of biodiversity in wetland environments, but also, just like humans can die of thirst and starvation, so can animals. Big animals like elephants, which require large amounts of water, often die in African droughts. What are some possible solutions? Well, there are quite a few. Let's look at irrigation projects. Countries that have regional shortages of water or variable rainfall can use irrigation systems to redistribute water and water the land. More efficient forms of irrigation like drip irrigation can also be used. Reduced leakage. Leakage is a huge problem, especially in countries with old pipe networks. In the UK, it is estimated that 460 million liters of water are lost every day through leaks. In the UK, there are targets for water companies to reduce leakages. Unfortunately, many companies are currently missing these targets. Also, the dam construction. Dams are controversial because they can bring many disadvantages as well as advantages. But if they are built sustainably, they can create artificial stores that can collect water in rainy seasons and distribute during drier periods. Also, water metering. Charging people per unit of water used rather than charging a flat fee can drastically reduce wastage and make people consider how and when they use water. Construction of wells. Many countries can't afford to have piped water to every residence, so wells become important in accessing groundwater supplies. As long as wells are used sustainably, they can be a vital source of water in many LEDCs countries. Also, international cooperation. When water is shared, it is necessary to have sustainable policies to reduce the tragedy of the commons, when all countries or regions take water for their needs and forget about overall impacts. The countries along the Nile are trying to create such agreements, but Egypt is hostile to any plans to redistribute. Also, sewage treatment. This is the removal of contaminants from water and from wastewater and household sewage. It requires physical, chemical, and biological processes to remove all the contaminants and to make safe this water. So, yeah. Also, virtual water. Many products, especially agricultural and industrial ones, use large amounts of water to be produced. For example, it's estimated that 4.5 thousand liters are needed to just produce one beef steak. It has therefore been suggested that arid countries should specialize in producing products that need less water to produce, while countries with an access of water should produce products that need a lot of water to produce. The products could then be traded between each other. So instead of water being traded, products with large amounts of water produce basically the products with large amounts of water used in their production are being traded. So this is virtual water. Also, desalination. With the growing shortage of fresh water, attempts have been made to desalinate seawater more efficiently. Traditionally, the processes have involved evaporating water off to remove salt, so this is thermal desalination. But increasingly, reverse osmosis is being used to force water through semi-permeable membranes to remove salts. Although the second process uses less energy, Both are energy intensive and require high levels of technology, so have been criticized and have not been widely adopted yet. But, I mean, I guess you don't really need to be able to explain this scientifically. You can just say desalination. So when you remove the salt from water to make it, usable. Also, conservation and education. Residents and water users can be educated about basic conservation methods which can reduce water wastage. Basic conservation methods may include half-flush toilets, showering instead of bathing, watering the garden after sunset, and recycling grey water, so shower water, etc., to use in the garden. So, what are some problems? I mean, it seems like we're just jumping on different topics, but, that's how the syllabus is. So, what are some problems of global warming? Firstly, rising sea levels. Since everything is getting hotter, then the ice caps in like the Arctics are melting, so the sea levels rise. Also, this results in coastal flooding, and so it's very expensive to make defenses against this, like barriers. Also, climate refugees, if the place is becoming too hot or too cold and you can't live there normally. Also, loss of biodiversity. As temperatures warm and sea levels rise, the habitats of many plants and animals will alter. Although some animals may be able to migrate to new areas, other plants and animals lose their habitats forever and become extinct. Also, changes in the Gulf Stream. The Gulf Stream that warms Europe could stop if the salinity of water changes around northern Europe. Also, desertification. That's a pretty obvious problem. If it gets too hot, too dry, then, places may become deserts. Also, loss of industry. Coastal industries like tourism and fishing will be affected as sea level rise and destroy holiday resorts, even just islands, and engulf fishing ports and communities. Also, flash floods. Rising temperatures will in turn mean more water is evaporated into the atmosphere. Because of the amount of evaporation, rainfall, especially convectional rainfall, will become more intense and cause more flash floods. Also, increased tropical storms. Some scientists believe that warming temperatures are increasing the magnitude and frequency. Increased tropical storms. Some scientists believe that warming temperatures are increasing the magnitude and frequency of tropical storms. And heat waves and forest fires are also problems with global warming, as well as melting permafrost. The melting permafrost not only releases large amounts of methane in the atmosphere, therefore increasing the greenhouse effect, but also releases fresh water into the seas, which may affect some of its ocean currents. Also, droughts and famines, which can, result in crop failure. And skin cancer, the disease. Because too much sun, white people like me get skin cancer. Okay, solutions to global warming. Firstly, renewable energy is obviously a pretty satisfactory solution. And hybrid cars as well. Recycling, that's a good solution. Afforestation and reforestation. So after you deforest a place and you use the wood to build stuff, well, you should plant seeds again to make so that the land can eventually grow back. Also, carbon sequestration. This is the capture of carbon dioxide from the atmosphere emission chimneys, so that you kind of, don't let the carbon dioxide escape. Also, international agreements. International agreements like the Kyoto Protocol that came into force in 2005 should help limit the amount of greenhouse gases being released in the atmosphere. Also, adaptation. This is when you change lifestyle to suit new conditions. But you could also, this isn't really a solution, but it's more of a mitigation. Firstly, you could build more sea defenses so that in case, the rising sea levels, you can still live normally. Also, you can use aircon and or heating to combat the heat, but this is technically a really awful way of solving it, because to get this, you need energy, and energy is made by fossil fuels, which greenhouse gases and blah, blah, blah. That's basically what's causing it. But it is a way of coping with it, I guess. Improved meteorology. You can predict and track events such as hurricanes and droughts so that populations can be warned and therefore will be able to prepare so that the impacts aren't as, awful. Also, disease treatment. If the strength of the sun's rays intensify, and diseases like skin cancer and eye cataracts will obviously increase. So we will have to improve prevention problems and improve treatment because, otherwise people will die. Desalination is another solution, and resettlement. Rising sea levels will create climate refugees in countries like the Maldives and Bangladesh. So, what are some positive impacts of global warming? Firstly, you know what? We don't technically need to know this, but I won't explain it. I will just say them because I don't think it's in the syllabus, but I just included it anyway. Firstly, improved Arctic navigation, increased agricultural land, reduction in cold death, release of fresh water, accessibility of resources, and reduced heating. So, some case studies. What are the impacts of water shortage on people and development? Well, in Ethiopia, that's going to be your case study, the loss of lives, because of water shortages, people die. So there are higher death rates due to malnutrition or, starvation. Also, less food is produced as crops die due to insufficient water. And since people can't make a living from farming, people migrate to urban areas like Addis Ababa, which is the place-specific reference, so do know it. Also, there is a rise in diseases such as typhoid as people use the same water for drinking, bathing, and waste disposal. And lakes like the Rift Valley Lake do dry out. So, another one, describe the ways in which energy supplies are being developed. In the United Kingdom, that's going to be the case study. Well, this is, by the way, a very tricky one. If it asks to describe one, you do say the Three Gorges Dam, but if it says the ways in which energy supplies, this means you need to talk about all of them. So just use this case study. So for instance, you would say United Kingdom, you would say tidal power is being developed in bays and estuaries like in the Severn estuary. Hydroelectric power is being developed in mountainous areas with high precipitation, such as the pumped storage scheme at Dynowork in Snowdonia. And wind power is also being developed off the coast of East Anglia and in Morecambe Bay in mountainous areas such as the Pennines. By the way, if you find it hard to remember them now, I'm going to make a video after with all the case studies again, and I'll leave like a printed version that you can print so you can learn them again. So yeah.